In this video, we're going to simplify a fraction that involves powers or indices. So I'm going to break this down for you. So I'm going to show maybe a couple of extra steps here that you probably normally wouldn't do. But I think just to sort of assist your understanding, let's break this down sort of one step at a time. And I think that's one of the beautiful things about maths is that it's a discipline that allows us to take something that looks fairly complicated, break it up into small pieces, and then sort of bring it all back together later on, hopefully into something that's a lot simpler. So let's start off with the numerator, okay? And you can see here that there's obviously some indices there and being multiplied together and sort of power to a power. So you can see some index laws that would need to be applied here. Let's have a look at the first bracket there. So that's negative 2a cubed b squared all squared. So let's square that first. So negative 2 all squared is positive 4. That's, in fact, anything to an even power will turn a negative into a positive. So if that was the power of 4, that'll be the same thing as well. So it'll be a positive answer. So 4, now a cubed squared is a to the 6. B squared squared is b to the 4. So we multiply the indices when we're raising sort of a power to a power, multiplied by 16 a to the 7b. Okay, and that's b to the 1, of course. And that's over the denominator, so that's 2a squared b to the power of 5. So 2 to the power of 5 is 32. Okay, a squared to the power of 5 is a to the 10, and b to the power of 5 is, no surprises, b to the power of 5. Okay, let's multiply the terms in the numerator through. So we're going to apply index law number 1 here, of course. Let's do the coefficients first. So 4 times 16 is 64. A to the 6 times a to the 7, so we can only multiply bases that are identical in terms of applying the index law, law number 1. So if the bases are the same, we add the indices, so a to the 6, a to the 7, that's going to be a to the 13. And b to the 4 times b to the 1 is b to the power of 5 over 32 a to the 10, b to the power of 5. Now at this point I'm going to break this up just a little bit further. I normally sort of don't do this in working out, but just to help your understanding that little bit more, a fraction can in fact be sort of expressed as a sort of a product of separate fractions. So a fraction that looks like this can be broken up. Let's express the numbers first on their own. So that's actually 64 on 32 multiplied by a to the 13. So I'm sort of representing this fraction as a product of 3 fractions. Okay, so that's a to the 13 on a to the 10 multiplied by b to the power of 5 over b to the power of 5. Now clearly we can see that's going to equal 1, since any term divided by itself is 1, except it sort of doesn't happen with 0. 0 divided by 0, well, we don't know what that answer is. It's undefined. Okay, so let's keep going. Okay, so 64 on 32 is just 2. Okay, a to the 13 on a to the 10, this is index law number 2. We subtract the indices, so that's going to be a to the 3 and times 1. All right, well, b to the 5 on b to the 5 is just 1. And yeah, just sort of bring it all together to a to the power of 3. All right, thanks for watching.